Hello class, and welcome to another episode of AP Chemistry. This time we're going to take a quick review look at stoichiometry, limiting reactants, and percent yield. By the end of this quick tutorial, you will know how to make basic stoichiometry calculations, find the limiting reactant, determine excess reactant, and calculate percent yield. Just for the record, I thought I had finished this video. I even published it to YouTube, and then I noticed that every slide only played for 12 seconds. So sorry for the change of clothing in the middle of the video. Let's jump into this. So when you're doing stoichiometry, let's look at a very basic equation. A makes B. Stoichiometry lets you determine how much A will make B, how much B will make A, how much you need, how many moles, how many grams. I mean, you could do anything. So take a look at this diagram I found. If you start with volume, you can use the density to get mass, turn mass into moles, and then you can go moles to moles. Remember, the only way you could go from one part of an equation to another part of an equation is with a mole ratio. It's the only way. What if you start with volume? You can use molarity to get moles, and then you can go to moles of something else. Start with number of particles, particles to moles, and then you can do the mole ratio. Same thing, once you find the moles of whatever you're looking for, if your answer needs to be mass or volume, you just keep going with your conversion. It's pretty cool. For some reason, limiting reactant problems can be intimidating, and part of that is because of the vocabulary. What is it asking? Well, let's just start with some basic definitions and the basic strategy for doing one of these problems. First of all, the limiting reactant is the chemical that runs out first. So in your calculations, you're going to be given an amount of both reactants. Sometimes it's moles, sometimes it's grams. Take both of those reactants, turn them into the same product. I usually just go to moles because it's faster. Whichever reactant makes the least amount of product is your limiting reactant. Think about cooking. Say you're making a cake recipe that requires 1 egg and 2 cups of sugar. You have 4 eggs and 4 cups of sugars. Well, the eggs will let you make 4 cakes, but the sugar will only let you make 2 cakes. So who's running out first? The sugar. How many cakes are you going to make? 2. You can't make more than that. So when you're doing these problems, you want to keep track of your information, and I do this below the equation. Once you determine who the limiting reactant is, you now know for sure how much of that chemical you had and used. You also know how much of that one product you will make. Use mole ratios to find everything else. Just go ahead, no matter what the next question is, find moles of everything. The excess reactant is the reactant that you had extra of. It's the one that did not run out. So a lot of times your question is going to be, well, how much excess reactant remains? What you really need to ask is, well, how much did I use? And if we have this gigantic tub of flour and we're making chocolate chip cookies, and in the end I ask you, well, how much flour is left? You're going to look at me and go, I don't know, Kelton, how much did we use? So to find out how much excess reactant remains, first find out how much you used, then do a subtraction. And I'll walk you through a problem. Let's go ahead and look at a problem. Determine the limiting reactant if 79.1 grams of ZN reacts with 163.1 grams of HF, according to that equation on the page. First thing you want to do is balance the equation. Do not assume the equation is balanced. Always look. So once you've balanced the equation, what you want to do is turn the amount of both reactants into the same product. And it really doesn't matter which product you choose. Sometimes I look ahead. If all of the questions have to do with, in this case, ZnF2, then I'm going to go to ZnF2. If all the questions have to do with H2, I'll go to H2. Otherwise, it doesn't really matter. Hopefully, by now you can understand the stoichiometry. I turned grams into moles and then did a mole ratio to get over to that product. What you should notice is that Zn will only make 1.2 1.21 moles of the product, while the HF will make over 4 moles. Well, who's running out? Zinc. Zinc is running out first. Zinc is the limiting reactant. By the way, sometimes I just write LR for limiting reactant. So zinc is the limiting, HF is your excess. So what do you know? You know for a fact that you use 79.1 grams of zinc, and you can easily turn that into moles. You know you make 1.21 moles of ZnF2. You do not know how much HF you used. Yes, you know what you have, but you didn't use it all. We'll tackle that next. So now that we know the limiting reactant, let's write down underneath the equation what we know for a fact. We know we have 79.1 grams of Zn. I went back and just did the quick little conversion to moles of zinc, and it's 1.21 moles. Well, I also know that I make 1.21 moles of ZnF2. We just found that out. So right here, right now, no matter what the next question is, go ahead and find moles of everything else. Well, you should notice that Zn, ZnF2, and H2 are all in a 1-to-1 ratio. Therefore, they all are going to be 1.21 moles. How did I get the HF? I just did a mole ratio. I chose to use zinc. You could have used any of these numbers to do a mole ratio, and it's just double. So 2.42 moles of HF. Now that you have moles, you can find grams of everything. By going ahead and just stopping for a moment and finding moles of everything, it's going to make every single question that comes next that much easier. Yeah, that's usually what I get from kids at this point in the problem. Because what's usually the last question? Find the excess reactant that remains. What? All it's asking you is how much of the one reactant you didn't run out of, how much is left? Well, first you have to figure out how much you used. We know HF was the excess reactant. We know we used 2.42 moles. Turn that into grams, which is the math there, 48.4 grams. And that's how much HF you used in grams. Now, why did I go to grams? Well, because initially I was given grams. I mean, it really just depends what the question's asking you. If it says how many moles are left over, well, just make sure everything's in moles. If it says how many grams are left over, just make sure everything's in grams. Well, we started with 163.1 grams. We used 48.4. Guess what? We have almost 115 grams left. A great application of the limiting reactant problems is finding the percent yield. And we'll do this quite often in our labs. Percent yield is simply the actual yield divided by the theoretical yield times 100%. Actual yield is what you actually got in the experiment. Sometimes it's called the experimental yield. Theoretical is what you were supposed to have made. And that is based on the math. That's based on stoichiometry. It's based on the limiting reactant. Remember, you're going to get two answers as to how much product you can make. The smaller amount is the amount that you're going to make. So when you do a percent yield problem, do the limiting reactant problem, find out how much product you actually make, and then just do a simple division. What I got divided by what I was supposed to get. Bam, done. So let's take a look at doing a percent yield problem. Let's go back to the previous problem we've been working with. What is the percent yield if you collect 119 grams of ZnF2? Well, we know we make 1.21 moles. We got that from the stoichiometry. Turn that into grams. You can see the stoichiometry there. You get 125 grams. In other words, we should have made 125 grams. But we only made 119, or we only collected 119. Could be because of faulty experimental procedure. Who knows? So all you do is take what you got, 119, divided by what you should have gotten, 125, times it by 100, and you get 95.2%. Hopefully, after this video, you feel better about basic stoichiometry calculations. Remember that labels are your friends. Labels must constantly cross off to result in the label you want. Finding the limiting reactant really is not that horrible. Determining excess reactant and what remains, find out what you had, what you actually used, and do a subtraction. That's it. And hopefully now you can calculate percent yield. We will be using many of these calculations in many of our labs.